Hi, I'm Savannah Dehart, and this is my presentation on the environmental fate of pesticides. So, throughout this presentation, I will be discussing the type of pesticides, the importance of pesticides, background information, historical development, key developments, future developments, the chemistry involved in pesticides, and the negative impacts it has on the environment. And I'll finally finish it off with a conclusion, and my citations will be presented at the end. There are three types of pesticides: insecticides, herbicides, and fungicides. An example of an insecticide is imidacloprid. It's typically used on vegetables, and it's a neonicotinoid. It acts as a neurotoxin to insects. It damages insects' nervous systems. It's one of the safer insecticides to use because it has a very low toxicity to mammals. And two very common imidacloprids used are Elice and Coraze, and they can be found in stores. They're usually pretty cheap. An example of an herbicide is glyphosate. It has low mobility, and a really good example of it is Roundup. The third type of pesticide is fungicides, and a really good example of that is pyroclostrobin. It's very toxic. One of the more popular fungicides of this type is Headline. It's a carbamate ester, and its chemical formula is C19H18ClN3O4. Pesticides are important because they increase food productivity. Pesticides can help increase the life of crops and prevent post-harvest losses. Without fungicides, fruit and vegetable yields would drop 50 to 90% every year. They also decrease the chances for food to be contaminated and possibly causing food-related illnesses. Background information. From the 1940s to 2000, herbicides were most commonly used pesticides. There was a global lost crop estimated at $550 billion. Crops lost because of disease were estimated at $220 billion, and losses that were prevented by crop protection were estimated at $455 billion. Actual global crop production was estimated at $950 billion, and attainable crop production was estimated at $1.5 trillion. One of the most widely used pesticides is Chloropyrophos. It was introduced by Dow Chemical in 1965, and it is used on corn, soybeans, broccoli, apples, and is also used very commonly on golf courses and other non-agricultural settings. Chloropyrophos was made to replace DDT, which was originally made to replace toxic lead arsenate. Historical developments. The earliest form of pesticides was a chemical compound with elements such as sulfur, heavy metals, and salt. Lime sulfur solutions were once used to destroy lice. Sulfur dioxide was used to stop pesticides and stop insects and other small pests. Sulfur is still used today as a pesticide. Arsenic 3 oxide was the first used as a pesticide because of its high toxicity to insects, bacteria, and fungi. The EPA, or Environmental Protection Agency, decided in 2017 not to ban chloropyrophos. In 2018, Hawaii banned chloropyrophos all across Hawaii Islands. And Roundup was introduced in 1974 and is still one of the most commonly used pesticides today. Some key developments in pesticides were synthetic and biopesticides. They were introduced in 2005. The global market for synthetic and biopesticides could reach $79.3 billion by 2022. This means it has an annual growth rate of 5.3% from 2017 to 2022. In 1996, GMO crops were commercially available. This allowed farmers to target specific weeds. BT, or Bacillus thuringiensis, is a naturally occurring soil bacterium Crops with Bt have been modified to produce a protein that is toxic to various forms of insect larvae. Bt was used to reduce the amount of pesticides used. Future developments: Greg Lowry of Carnegie Mellon University is creating a nanoparticle coating that will replace pesticides. These nanoparticles are 99% effective. Lowry's team coated the nanoparticles with gold, then coated the AUNP, or gold, with different coatings. Nanoparticles can reduce the amount of pesticides needed, and they are way less harsh on the environment than pesticides used today. Alternatively, the non-targeting citrate AUNPs, or gold nanoparticles, were dispersed randomly across the leaf surface. The antimicrobial nanoparticles they target toward the stomata and other common pathogen entry points that could intercept these invaders before they have a chance to enter the plant. Chemistry involved in these pesticides. Another common pesticide used is aldrin. Its chemical formula is C12H8C16. It's used as an insecticide. It's insoluble in water and non-combustible. Another common pesticide is Chloropyrophos. Its chemical formula is C9H11Cl3NO3PS. Insecticides usually mix with oily liquids before applied to crops, and it doesn't mix well with water. These two pesticides are not soluble in water, and they can be used to control ticks on cattle and is used in some flea and tick collars on pets. A commonly used fungicide is pyraclostrobin. Its chemical formula is C19H18CLN3O4. Up in the top right corner is it's the molecular formula for pyraclostrobin. It's carbamate ester. Negative impacts on the environment. Insecticides do not mix well with water. Pesticides get washed away by rainfall and can get into water sources by runoff. Pesticides can travel far from where they were originally applied. They drift in the wind when sprayed in gardens and can run off into streams and rivers when washed away by rainfall. Pesticides have caused long-term damage to soils and water. They have disrupted ecosystems, and they have caused death or injury to non-targeted organisms, and some bugs have grown resistant to pesticides. Out of pesticides, insecticides are the most harmful. Fat-soluble pesticides can spread a little bit further than the water-soluble pesticides because they get on animals, and when animals travel, they take the pesticides with them and get them on other things as well. And they're very toxic to the animals. So it creates higher levels of toxicity in the environment's ecosystems. Water-soluble pesticides, they get in the rain runoff, and then they get on other things that they're not supposed to be on, and they can infect the water sources surrounding where they were sprayed. An example of an environmental disaster caused by pesticides is when chlordecone was banned in 1993 and farmers continued to use it. The article that I got this from was the SEPA, or the Safe and Effective Pesticide Applications. It was a little story at the end of the article. I got it from the Environmental Impacts of Pesticides. So it didn't specify where this happened, but it was definitely somewhere in South America. But the farmers continued spraying from 1993 to 2002. This caused high levels of toxicity, causing banana plantations to shut down, and sources of drinking water were contaminated, and they are still estimated to be contaminated for decades. This is a really great picture that I found on Bing, and it shows the pesticide cycle, so all the different ways that pesticides can be taken from where they were sprayed and get into other parts of the ecosystem. So here it shows that they can be vaporized into the atmosphere and degraded by ultraviolet light, but it cannot still be, it goes up into the clouds, so it gets deposited by rainfall the next time it rains. It's absorbed by the crop, but it also leached below the root zone by rain or irrigation. It can be degraded by bacteria oxidation or chemical hydrolysis. It adheres to the soil particles, and it gets leached to water sources, and it gets into surface runoff to lakes and rivers, infecting the water ecosystems as well. So my very basic conclusion is that pesticides are really bad for the environment, but good for crop production. And these are my citations. Thank you.